Hi there, this is me in editing. I just wanted to make a little note before the video started that this one got to be a bit of a long one. In fact, I think it's about 40 minutes. So I could understand if you don't want to sit around and watch that whole thing. I would probably recommend watching it in parts. There's a lot of good information and I still think it's valuable, but maybe watching it in one go might be a bit much. Alternatively, if that's just not your thing, then you can just skip this one and wait for the next one where I'm going to talk about more theoretical stuff in a shorter video again. In this one, we're basically just going over writing our first basic program and getting arguments off of the command line. Hello and welcome back to my Getting Started with C course. In this program, we're actually going to be writing our first somewhat useful program and finally getting around to explaining what this mess means. We're not going to do really any theory, it's going to be all programming, so hopefully you can follow along and let's get started. So to begin, I just want to give you a bit of an idea about what we're doing. So we're going to create a program that we can run from our command line that will generate a random number for us. Okay, so the way this program will work is that we will be able to call our random program, and then we're going to be able to specify two numbers. And when we run it, it will give us back a number between those endpoints. So if we wanted to simulate rolling a dice, we could do 1 and 6 and hit enter, and you see that we get a random number of 3. Now don't worry about this, in our one we won't have this bit of random information here, that's just for me when I was debugging the initial version. So if we run it again, we'll see that, okay, this time we got 3, but perhaps, here we go, 6. So it basically works as a dice roll. And it just works by running the program and then giving the range on the actual command line itself. So we're going to learn how to do this now. Okay, so to start, we're going to create a new file so we don't override our hard work from the previous episode. And to do that, in VS Code at least, there's a little plus icon. So if you open your side explorer here and click that, there's a little plus icon for file. So if you click on that, we're just going to call this random.c. I mean, you can call it whatever you'd like, but I'm going to call it random.c because it matches up, and .c so we know it's a C file. Okay, the first thing we're going to do, as always, is define our main function. So int main, and like so. Okay, we've got our main function. Now at the moment though, it's probably missing something that you guys are used to seeing, which is all the stuff that goes in between there. So let's describe what exactly this means and break it down. So what we'll do is we'll type it out and then I will explain what it is. So inside our main function here, we type int, so we know it's got something to do with an integer. We type int, so we know it has something to do with the integer data type. And then you can call it whatever you want, but the standard is to say argc, comma, and then we're going to say char, star, a little asterisk icon here, argv, open and close square brackets. Okay, so in the last episode we learnt about data types and variable declarations, and so we could probably read this a little bit better. We're sort of declaring that we want an integer to exist called argc, and we're also declaring that we want a character to exist called argv, but then we've also got these square brackets. It's a little bit more advanced than what we saw last time. But essentially, this is the way we actually get inputs from the command line. So you'll recall just before when I ran our random program here, I gave it a starting and end point to generate a random number. And the way we actually can process what the command inputs are inside of our program is through using these variables. When a C program gets called and it first tries to run the main program, if any arguments were provided on the command line, it will give them to us through these variables. The first variable here corresponds to the number of arguments that were given to the program, where arguments is just some sort of extra information that we passed along after we ran the program. Okay, so in this case here, the number of arguments that we pass in is actually 3. Okay, because the name of the program itself is also passed for some reason. I believe that's a Windows thing. If you're on Mac or Linux, it'll probably only say 2 arguments are passed because it won't provide this name as well. So yes, this is the number of arguments that were provided when the command was run. This over here is something a little bit more technical. It's actually an array, and an array is essentially a list of multiple variables. And for the moment, we know that this is a char star type, and that's actually a bit more complicated. We'll cover what a pointer means and what this really means in a later date. But for now, you can just think of this as referring to some sort of string of text. So we've basically got a list of different text inputs. So the way you can imagine this might be working is when we run this code, first of all, we have this variable, which will tell us how many arguments were provided. And then we have this array of characters, which actually provides the arguments that were passed. Using these in conjunction with each other, we can then start to break down and get access to each of the subsequent arguments. All right, so the first thing that we're going to do to test this principle is just print out the argc variable. So to do this, we need to remember to include, remember that's a hash include statement, our stdio.h file, okay? Standard input output header file. This just gives us access to all of our printing commands on the terminal. All right, so the command for printing formatted text to the screen, as we know, is printf, or print formatted. Because it's a function call, open and close brackets here, and end with a semicolon so that the compiler knows that this is the end of our statement. Now we've got to tell it what to print. So in here, we're going to say the number of args provided was, and now because we want to print out an integer, which is a number, we need to use the format specifier %d. Remember that you can actually just look up C format specifiers in Google and you'll get a full list of all the different ways to format different data types, which we looked at in the last episode. Okay, and then we're just going to follow it up with a new line character. What this will do is once this finishes printing, it'll then put the terminal onto a new line so that we don't end up with a messy looking format. I would recommend pretty much always putting a new line at the end of any of your print statements. Okay, now that we've done that, we need to give it the variable that we're trying to print. Now we've specified that we're trying to print a number or a digit, and so we go to give it the thing to print from. And in this case, it's our argument count here, or argc. So we're just going to say print argc. Now this is an integer variable, as we learned in the last episode. If we save this program and come down and compile it, remembering that our command to compile it is gcc, then the name of the file we're trying to compile, in this case, random.c, that's what we called our file. If you named yours something different, make sure you use the right name down here. And then we're going to specify the name of the output program. And I'm just going to call it random.exe. Because I'm on Windows, I'm including this .exe bit. If you're on Mac or Linux, you do not need to include the .exe bit. And now I'm going to hit enter, and we didn't get any errors, so we know it ran properly. Now, if we run random, let's see what happens. So typing random and hitting enter, we see that the number of args provided was 1. And this is correct, because remember, this arg count just tells us how many different separate pieces of information we submitted on the command line here. And if you're on Linux or Mac, this number might say 0 because it only counts the stuff after the command. So just be aware of that slight difference. Okay, so let's try running it again, but instead we'll just give a bunch of random different numbers afterwards. Okay, so counting how many different pieces of information we have here, 1, 2, 3, 4, we would expect that the number of args is going to be 4. So let's run it, and perfect. Now we can see how many arguments are passed after this matter. Okay, cool. But how do we actually get access to those inside our program? Well, if argc is just the way of knowing how many arguments were passed, then argv, this array, is actually the list of each of them. It's important to note that this list is only as long as the number of elements provided, and this will be important in a moment. Let's first start by printing one of these numbers back to us. Okay, so how are we going to do this? Well, all we need to change is we need to print argv, and we're going to see some interesting behavior when we do this. So if we try and compile this, it looks like it works fine, but what happens when we run it? That's very bizarre. All of a sudden, even though we've given no arguments, we have this random number printed out. And what's actually happening here? Well, that's actually got to do with what kind of data type this argv thing is. You see, this star is actually important. If I just wanted to declare a variable that contained a single character, all I would do is type char and say, like, I don't know, my letter, and then I would just set it equal to a single letter, say A. And that's perfectly fine. So what does this star mean? What's the difference between a char star and just a straight up char? Well, it's actually because whilst this is a pure data type, it's a single character that can store a single character of information, this is actually called a pointer. So a pointer is actually it's a number that refers to an address in memory. If you can think of your computer as having a whole bunch of boxes, if you remember in the last episode when we talked about we can store variables in all of these boxes, and memory has hundreds of boxes, even thousands of boxes which we can store information in. And each of those boxes has a specific address assigned to it, right? And they start from 0 and they work all the way up into the thousands. And basically, what a pointer does is instead of storing an actual value, it stores a number which points to one of those boxes. So in this case, it's saying that the box that is stored at location roughly 13,200 in memory is what actually contains the information that we're trying to access. Now, that's a lot to take on conceptually, given that we're not really looking at anything graphically, but I am going to do some episodes in general about computer memory, and I'm also going to do the next episode in this series specifically focused on pointers and arrays, and it'll actually probably be the next few episodes. So if it sounds overwhelming now, don't worry too much about it. For all we need to know is that this actually doesn't contain information specifically. This is actually a number because of this star. All right, so with all that said and done then, how do we actually get the actual information that's stored in this array? Well, I'm just going to come up here and leave a comment to show you a little bit about how an array works. So here we can see that we've got argv and then we've got these square brackets. And what we can think of these square brackets as being is actually like containing a list of information. So if you've used Python or JavaScript or some other language, you're probably used to seeing things stored in a list in this format. Here we have a list of 3 items. And this is what is happening here. An array is just a list of information, okay? And so how do we actually get the information out of this list? Well, if we look at it here, we've got 3 items. And so it might stand to reason that if we type argv and then we say like number 1, let's make these letters to make this a little bit less confusing. It might stand to reason to say that, okay, well, if this is just the list of items, then if we ask for, say, the first item in the list using this square bracket to say, hey, give us the first item, you might expect that this would give us A. However, in C, this is not quite how it behaves, because arrays start counting from 0. And again, this will make a lot more intuitive sense to you in the next episode, because I'll show exactly why we start counting from zeros in most programming languages. And it's really easy to understand once we sort of go over a bunch of fundamentals. But for now, all we got to know is to access anything from the list, we start counting from 0. So whilst there's 3 items in this list, to get them, we would actually ask for index 0, index 1, and index 2, respectively. All right, cool. So with that being said, let's try and print out something that is stored in the 0th index, okay? And this will error, but let's just see what kind of error we get, okay? So what we're asking for now is we want to print, here, let's go, change this. The first argument was, and what we're trying to do is to print, that first number that we provided on the command line, okay? And there's 2 bugs with this, but we're going to see in a second. So let's just compile it again down here in our console and run it and see what happens. And what's going on there? Nothing has really changed. Well, that's because we have issues with the way our data types are actually working. You see, here we are attempting to print something that is a digit. So no matter what kind of information is stored in this first index, no matter what our first argument is, it's going to try and convert it into a digit. But if you remember before, it also includes the name of the program when we run it. So the first index is actually not a number at all, it's some text. And so this number here is just the C language attempting to convert that text into a digit. So actually what we need to do is ask for the second index in the array, which is position 1. Remember, we count from 0. So 0, if we come down here and look at this command we run, you can think of the 0th element of this command is this, us calling the program. The second element, which is index 1, is this. This would be number 2, and this would be number 3. Okay, if you're on Linux, again, you might need to play around with it a little bit. This might not be included, and 0 might refer to this number, and it might already be working for you. But now, if we just, we've just made this change to test for 1. If we compile this program again, and always remember to both save and recompile your program when you run it, because otherwise you won't see the changes and you'll be very confused as to why nothing has changed. So if something doesn't look like it's changed like you would expect it to, always remember to save and recompile and then run again and see if that fixes the issue you are having. So doing this, it doesn't look much better. In fact, we can see that the number is different, but at the same time, we're still getting unexpected results. Okay, so this is the most important bug in this whole thing. Remember that our array is actually an array of characters. See, this is a char data type. So if we get any element out of it, you'll see that it's actually going to give us a character. If you're using VS Code or some other editors, you can hover over a variable and it'll try and tell you what type it is. And you can see here that this is actually a character, not actually a number. So how can we fix this? Well, if you remember in the last episode, I said you can just look up all the different format specifiers. Let's just look up a list of C format specifiers on Google and see if there's one that can display a character type rather than trying to print a number. So doing that, you might come to something like this. Now, this is a pretty good reference, but there's heaps of websites and they'll all give you basically the same information. So you just got to search C format specifier, just this little thing here. And I can, if I remember, I'll try and link this one in the description of this video. So you can see here, there's heaps of different things we can format out to the terminal. And this is the one we've mainly been using to print a signed integer or a digit. But if you come down, you'll see there's also %C, which is used to print the unsigned character. In other words, just a char type. So if we come back to our program and instead try and format this variable as a character, let's save it, recompile it. If you're wondering how I'm going through my command history, use the up and down arrow keys on your keyboard and you'll be able to quickly move back and forward through your history of things that you've inputted on the command line. Okay, so recompiling, and now trying again. Now what's going on? Well, we've got a box, so it kind of looked like it tried to work, but it didn't really, and this is a rabbit hole that will never end. The reality of trying to do it this way is really tough, because this is actually a pointer that needs dereferencing, and there's a lot of technicality to it. Okay, so instead, let's rethink our approach here. So what I'm going to do is I'm going to delete this. And let's think about what we're really trying to do here. And let's write some comments. Okay, so we want to generate a random number between a min value, a minimum value, and a max value, or a maximum value. Okay, how are we going to do that? Well, first, we need to get min and max values. Then we need to store them somewhere. And these are what we're going to read in off the command line. And then we need to somehow, we don't know how yet, somehow make a random number. Okay, let's start working through this step by step. Okay, so generate a random between is our overall goal, but let's look at our first step here. We need to get min and max values and store them somewhere. Okay, well right now, the only thing we really know how to do is store some numbers. So let's go ahead and do that. Okay, so remember, if we're trying to store some integer numbers, we need to declare new variables. So let's declare int min and int max. Note that we don't actually have to set these equal to anything. We can just simply declare them to say, hey, I want to make these variables exist. Okay, so now we have an integer called minimum and an integer called maximum. Awesome. Now we need to find a way to actually include or how to actually get the information from the command line into these variables. And this is where things start to get a little bit more complicated. Okay, so what we can do is actually use a function called scanf. Now, if you've watched some other C tutorials or done some basic C programming, you will have seen the scanf function that just looks like this. And what that does is it actually searches on the command line for some user input and then tries to store it in a variable. What scanf does is it actually scans a string for some kind of information and stores it in a variable. In this case, we can just read this as string scanf or string scan formatted. I find it easier to sort of read the expanded names for them. Okay, so if we hover over it, you'll see that our IntelliSense here doesn't really give us much information as to what we need to provide to this scanf thing. So let's just Google it. again, Google is your friend when you're learning to program. So just search scanf, right? That's the function we're trying to use. And let's click on the link here. You see I've already been to it. And we can start to understand what we need to provide. Okay, so the C library function scanf reads formatted input from a string. Okay. And then it tells us that, okay, so we can give it the string that we want to scan, and then the format we're trying to scan. And in fact, if you go down, we can actually see that there's lots of different use cases for it. But there is essentially a way which we can then read from a string and store that information in a variable. Okay, so let's do that. So let's first try and read a min value. So what we need to do is say that, or provide the string that we need to scan, okay? And in this case, we're trying to scan the arguments off of the command line. Now remember that when we submitted a command, say like this one, everything gets split up by spaces and then given to our program in an array as string types. So we will have random 32, 325, and this number all sitting in this array which we have access to. And counting from 0, this would be 0 and this would be 1. So assuming that we want to read some value into our minimum value, we need to read from this array, we need to read index 1 to get the first number provided after we run the command. Okay, again, this is a lot to go over. It's pretty intense, but it's a pretty high level concept, and it is not very common that this is explained to you. So I'm trying to do my best, but in the next few episodes, I'll get more specific with how that actually works in the background, and we'll look at some diagrams to help you get sort of what's going on with the memory. Anyways, back to this. So what we want to do is we want to scan the first, or rather the string in position 2. Remember, these are all get broken up into our array, and the string in position 2, which is actually index 1 because we count from 0. So we want to read from index 1, that's a string. We want to try and read a number. Okay, and the way we tell it that is we use the same format specifiers we use in printf. In fact, anywhere you see these f sort of functions, they probably work using the same format specifiers. Okay, and now what we need to do is give it somewhere to read that number into. Okay, and in this case, we're trying to read into min. So we need to do something tricky here. We need to do and min. Okay, and I'll go over that in a second. Okay, so let's leave a comment to ourselves here so we understand what's happening. Read from arg1, okay, the second index in our list, or read a digit, or read a number even, an integer, and in brackets we'll just say that's our %d thing. So we're trying to read an integer from the second argument in our array into the min variable. So what this hopefully does, it will read the value provided into and store it into this variable, okay? So that's what we're trying to do here. Now, if we hit enter and go and, let's see, type in, let's print this back out. So we're going to do another printf, and we're going to say the min value was, and then we will do a digit because we're trying to print a digit, followed by a new line because we want to keep our formatting tidy, and then let's just put min here. So hopefully what will happen is, if we include our semicolon at the end and save, hopefully what we will see is that the number that we provide will get printed back out to us. Okay, so again, formatting for a digit, and then that will get replaced with the next argument in the list. So coming down here, making sure to recompile, of course, and running our program with a single argument and hitting enter. Perfect. So now you see whatever we provide after the random command will be passed back out to us. Now, what happens if we give it something that's not a number? Say ABC. Well, it just defaults to 0. It can't read this as a number, so it'll just fall back on 0. Now, in a proper program that you end up writing down the track, you'd want to do a bunch of error handling. You'd want to check that the user provided the right kind of input, but we don't really care about that right now. We're just trying to sort of play around and make a little tool for ourselves. Okay, so let's repeat this step, but using it for the max value. So we can just copy this code and come down and paste it. Okay. And what we'll do here is now there's a few bugs that, or a few things, not bugs, but a few things we need to keep track of that we need to change. Okay. First of all, if we leave this as arg1, then we're just going to be reading the same value for maximum and minimum. So we're going to want to read the next argument provided. Okay, so we read the minimum. If we go back to looking at a command like this, it would be reading the minimum value and then reading the maximum value. Okay, so we need to make sure we update our position in the array to read the next number. The next thing we have to do is make sure that we read into the correct variable, okay, into max. And then here, we're going to put max and max just so that we're seeing both things be printed nicely. Saving. Now, a brief note on this little and symbol. Why do we need it? Okay, well, this is more complicated, but for right now, I'm going to explain it in a more simple fashion that I think will be sufficient. When we refer to a variable using just its name, the value inside of it will get looked up and it will be replaced by whatever value it stores. Basically, we're searching saying, hey, what's stored inside of here? However, if we want to put something inside that box, we just need to put an and before it. So in this case, we're putting an and before it because we're telling scanf, hey, we want you to put it into this variable. Meanwhile, printf, we want to read from that variable, so we don't use the and. Now, this isn't actually a consistent rule that always holds true. There's actually a different meaning, but I just want you to understand it as that for now. And in the next episode, we'll explain it in more detail. But for now, just understand this as we're trying to read something into this variable, so we put an and before it, and same here. And then for both of these ones, we're trying to read out of them. And that's the same reason why there's no ands up here. That's because we're always trying to read out of these values. We're never trying to read into them. Okay, so recompiling our program, once again, always remember to save and recompile. Okay, and now if we run our program, we should be able to provide it with two separate arguments. So now random, 1, and 4. Okay, and hitting enter, and you see perfect. So the min value was 1, and the max value was 4. So we've got commands off of the command line. All right, now this is a good place that you could stop watching if you wanted and like come back to it later because I know this is getting a bit long. But for those of you who want to stick around, let's see how we can actually generate a random number using the command line. Okay, so to do that, we're going to need to include another library. So if you go hash include here and include the standard lib.h. Okay, we haven't used this before, but this is a bunch of standard library functions. There's a bunch of really useful utilities that we might use in our program. And inside it includes some random number generation, which is really useful. So let's save that program. Let's save our code here. And now we need to know, okay, so how can we generate a random number? Well, inside this random library, there's a function called rand. Right? And all this does is just generate a random number between 0 and the maximum number size that your machine supports, which on most modern computers is about 2.1 billion something, I'm pretty sure. So it'll just generate a massively crazy number. And we can actually display this as well. So let's just add another printf, print formatted, and say a random number is, and then format it with our %d modifier and a new line so we keep neat. Okay, we can definitely do this. A common thing to always miss is if you put a bunch of brackets next to each other, people often forget to put the right amount of brackets. So sometimes if you're getting errors, it's good just to count that you've got the same amount opening and closing. Most code editors will highlight that for you. So you see we've got one opening, 2 openings, and then we've got 1 closing, 2 closing. So we know that our brackets are balanced. So what's going on here? Well, all that's happening is we're trying to print something, and then we're just going to print the value of whatever this random function generates for us, which is going to be different every time. Or at least in theory, it's supposed to be different every time. But let's have a look at what happens here. So compile our code. Oops. All right, compile your code correctly. Don't do what I did. And let's just call our random function. Again, you can give it 2 different arguments. And boom, here's a random number. Seems pretty cool. Let's run that code again. And again. And you might be noticing something. It doesn't really look like this number is that random. In fact, it's exactly the same every single time we run it. And why is that? Well, computers don't really know how to generate a random number. It's actually not possible for them to generate a truly random number. So instead, we use something called a pseudo-random number generator, which is an algorithm which is designed to make numbers that appears kind of random. The way it works in C is that it just uses the same algorithm every time. And that means it will spit out the exact same number every time for the first time we call it. So how do we avoid this? Well, the way to avoid it is to actually set a seed. So I don't know if you've ever played, I mean, this is a bit of an interesting reference, but for those of you who have played like Minecraft, you might know, but there's a concept of seeding a random number generator. We can basically give the computer a base number to use in its random generation. And as long as we keep the seed changing all the time, then it will never repeat the same random numbers. Okay, so the way to set a seed for the C standard random number generator is to use something called srand. Okay, and we call it like this, and it takes a single value as an argument, which is the seed we want to set. Okay, so let's say we want to set 1,000 as our seed. Okay, so now what we're doing is we're actually telling it, hey, use this seed, don't just use the default one. But some of you might expect that if we recompile and run our code again, this doesn't really solve our problem. Now we're just getting a different random number every single time. So what we really need to do is make our seed change every time we run our program. And probably the easiest way to do that is just to set the seed to whatever time of day, you want, right? So how do we do that? Well, we need to import yet another library. Now, it's very common to use a bunch of libraries in your C code, and especially all of the standard ones. So if you see includes that are inside these angle brackets, that means they're part of a standard library, and they're very common to use. So we're going to include one called time.h, which will give us access to some functions that give us the time. Okay, and what we can do is set the seed as the current time. And one really technical thing we need to remember to do is put a null in here. Okay, and a null basically means a no value, a nothing. And that's because time tries to take a reference point, and we just want to say, just give us the current time. Now, I don't want to explain this too much. You can look it up if you care. But for now, just trust me. If you want to get the current system time without like any other random information, if you just want to include like what's the current time in seconds, then this is how you get it. And that'll return it as a number. So then we can give that number to srand to set our seed as the random time in seconds that it is when we run this program. Now, assuming that we don't run our program the same time within 1 second, it means that our seed is going to be different every single time. So if we recompile, and now we run our program, say like so, okay, that's our first value, but running it again, now you see we're getting different numbers. So now all that's left to do is work out how we can keep this value within the range that we specified. How can we do that? Well, that's actually fairly straightforward. All we need to do to be able to do that is just use a modulo operator. Okay, so let's do modulo. I'm just going to put a placeholder here for now so we can really examine what this is. So I'm just going to zoom in. That's our operator. It's a little percent symbol. Okay, so this is a percent symbol inside a string. That works to format some text and whatever. But out here, this is where we can just do like mathematical expressions like random plus 10 or random minus 10 or random times 10. All of these would work because we're just timesing a number with another number. But a less commonly understood operator is the modulo operator. And what this does is it actually divides the number on the left by the number on the right, and then it returns the remainder. Okay, so for example, as a comment, if we divided 7, if we did 7 modulo 2, basically we're dividing 7 by 2 and then returning the remainder. Now 7 divided by 2 obviously gives us 3, remainder 1, okay? Because 2 goes into 7 3 times with 1 remainder. If you're not super comfortable with the maths of this, don't worry. Not all programming is maths. If you don't understand it, you can just copy this across. But if you are interested, that's basically what's happening. So when we do a modular operator, we just get the remaining number. But what this means is it's actually a really useful way to force an integer to stay within a maximum value. If we do rand modulo max here, it means that any number that gets generated will automatically get wrapped within our max number. Okay, so no matter how big random is, it will end up getting wrapped down and put within like less than or equal to this max value here. So let's just see this in practice. If we compile it and then run our code again, Note that our minimum value, we haven't implemented that to work yet, but right now our random number should stay within our max value. So let's just use 6. Okay, perfect. So now our random value is 3. And this time we got 1. And running one more time, here we got 1 and 4. Okay, so now all of our random numbers are being generated and they are all less than or equal to this max value. Okay, so how do we implement our min value? Well, that's also relatively straightforward to do. All we need to do is simply make sure that our min value is the smallest thing that can be generated. So instead, if we say our minimum value that we could possibly generate plus the result of random modulo max. Okay, so how does this work? Well, it is possible for this expression to return 0. If the random number that we generated is perfectly divisible by our max limit, then this expression here will be 0. And when this is 0, it means that our minimum number will be left because any number plus 0 is just the number by itself. So in this example here, what we're actually generating is a number that will be greater than or equal to our minimum number and less than our maximum number. And this will just more or less work. If we save this and recompile, always recompile, and now we run it and say we want a number between, say, 4 and 8, and hit enter, you'll see that no matter how many times we run this, our number should be between 4 and 8. Now you'll notice, and this, I was hoping this would happen at some point, we did get a bug here. We got 9. What? How is that possible? Well, now the thing is, it is actually possible for this here to generate the max value, right? So what happens is, if this is the maximum value, or some high value, but we've also said that we want to generate a minimum value, and we're adding them together, say that this generates 5. Now, 5 is a number that is less than our maximum, so it's okay. But remember that in that example, we set our minimum to 4. So when that happens, 4 plus 5 is 9, and now our output's 9, which is bigger than the maximum we wanted. So how do we fix this? Well, really, this is now actually kind of boring, and it's just a detail of thinking it through mathematically, which a lot of people don't really want to deal with. But the way you do it, and I did this beforehand just as a reference, is using this kind of expression here. So what's going on? Okay, so it's similar. We basically have our min value and our max value, but then we need to get the difference. It's a whole mess. So let's invent it ourselves, okay? So we're going to keep this, but what we need to do is change how we generate the other side of it. And the easiest way to think about this is we want to generate a number that is going to stay within our maximum value. So if we set our minimum to 4 and the maximum number we want is 8, then the outcome of our random number generation can only be 0 through 4, because if it's any number bigger than 4, 4 plus that bigger number equals 9, this is where we get our bug. So the way we do this is just do max minus min, okay? And this will, and then if you want to also include the output range, you do +1. So let's just do this and let's just see what our results are like, okay? Again, this is more of an implementation of maths. I'm not here to teach maths. I just want you to understand the code. So if you're not following, don't worry, just trust me. What this will do is it will make sure that our output is always greater than or equal to our minimum value and less than or equal to our maximum value. Okay, so if we recompile one final time and run, now we will see that our numbers will always remain within the range. And we can make this range a lot larger. We can say 1 and 100. And now we're getting all the random numbers in that range. And that's it. Program done. So I know I would have lost some of you towards the end there, but that's essentially how or why these int, arg, c, char, arg, that's what they're there for. It's so that we can pass arguments that are provided to our program and use them inside of our program, which can be really useful for little random number generators like this. So this is sort of your first program that you will have really written. And in the next episode, we're going to go back to theoretical. We're going to look about pointers and arrays and strings and manipulating them. But for now, I just wanted to give something to actually go off and actually go and make for yourself. Anyways, thanks for watching. Hopefully you managed to stick around. I know that was a long one, and I'll see you in the next one.